Hello everyone, I am S. Bhavan Kumar, Assistant Professor in the Department of Computer Science Engineering and St. Martin's Engineering College. Today video session we are going to discuss cluster analysis in data mining. First of all, what is data mining? Data mining is extracting the knowledge from large amount of data. Say for example, nowadays everybody using mobile phone, laptop, cloud, right? So we need the databases and data sources. Here, there we have to retrieve the data from the large databases or data set. It is not an easy task, right? So here we need the techniques. So here we can follow the data mining techniques. In data mining, there are so many techniques are there. For example, classification, association rule mining, and clustering. Today we are going to discuss cluster analysis. So what is cluster analysis? What is cluster analysis? Clustering. What is clustering? Clustering is a grouping of data object. For example, assume that I have one bowl. In that bowl, there are three different color balls. Right? Assume that I have red color, green color, blue color ball is there. Right? Now I am going to segregate red color as a one bowl, green color as a another bowl, blue color as a another bowl. So this process called the clustering. Clustering is nothing but grouping of data object or data points. So the clustering is the process of exploratory the data analysis and identify the pattern and relationship between the data. Right? So clustering, here there are many algorithms are there, such as k-means clustering, hierarchical clustering, density based clustering. Right? So now you understand what is the clustering. So clustering is nothing but the process of to find the similar object in order to form the cluster, right? Say for one example, see this image, have three fruits, right? Apple, strawberry, lemon. So they are all are in the combined, not in the order, not in the structure manner. These all are combined. It is in the unlabeled data. Now we are applying the clustering algorithm. We have to segregate apple are one group, lemon are one group, and strawberry are one group. So this process called the clustering. Here we classify the data, right? You can see one video, you can get idea. So see for this video, these are the data points. So these are the data points are located, right? These are the data points are located. Now we have to choose one random data point. Find the similarities of data points. Right? For example, I will choose on these random data points. Find the similarities. Right? So these data points closest to this data point. This data point is closest to this one. So like that, all the data points closest to each other. Right? So now it is all in the all the data points are in the one group. Similarly, for see here some distance are there. Here there is no data points. So we can start from here one random data points, find the similarities. These are all the data points similar to each other. So these all and all one group. Similarly for here, right? Similarly for here some distance are there. Now, then we can move for the next data point. Find the similarity. This data point similar to this one. This data point closest to this one. This data point is closest to this one. Right? Now we can make a one group. Right? Like that we received the three clustering groups. Right? So for example, I will say for one example, I have one data set. For example, I have one data set. In that data set, I have the image of a bicycle, car, and buses. Right? I have the data set. In the data set, I have car, bike, and bicycle. This data set I have in the folder, right? So these are the unlabeled data. So that means what? It is a not proper structured manner, right? Now we are going to apply the clustering algorithm to segregate. Unlabeled data into labeled data. So that means what? So first we can car images having some similar features. All the car images having the similar feature data points, right? So we have the car images, we can keep on one group, right? All the car images you can keep contained in the one group. Similarly, for all the bike image, keep in contained in the one group. Similarly, bicycle, right? So like that we can make a 3 group. Then easily we can classify the datas. Then we can easily to classify the datas, right? So this is the process of clustering algorithm, right? The properties of clustering. So clustering needs some requirements, right? See the properties. The first property is clustering scalability. Clustering should be on more scalable because we are handling for large amount of data. We are handling for huge amount of data. So the clustering should be on more scalable and efficient. And the next point, high dimensionality. So the clustering algorithm should be on able to handle high dimensional space. High dimensional space along with the data of small size. For example, I got only blur image. So in that case we cannot get the accurate data points. In that case we cannot get the accurate data points. So the blur images also it should be on handle, right? The next algorithm usability with the multiple data kinds. So we received so many types of algorithm. For example, I will receive image data, I will receive video data, I will receive audio data, I receive tabular data, right? Whatever the data, the clustering will be performed more efficient. The next one, dealing with the unstructured data. So see, some databases contain missing values and noisy values. So in that case also the clustering should be performed very efficient manner, right? The next, interpretability. So in the clustering outcomes should be on interpretable, comprehensible and usable, right? So this interpretability reflects how the easily we can understand the data, right? So these are the properties of clustering techniques. Next, types of clustering techniques. So there are 3 types of clustering techniques. So first, today we are going to see 3 types of clustering techniques. One is the partitioning method, hierarchical method, density based method. So these 3 techniques today we are going to discuss. First we are going to discuss partitioning method. So what is partitioning method? The name itself, partitioning, right? Partitioning means what? We have to make partition on the data in order to form the cluster. We make partition on the data in order to form clusters, right? Say for example, so these are the data points are located. Say for example, these are the data points are located, right? So each object, each data points, it is called P, right? Each objects data points we can call the P, and complete grouping the data that we can call the N partition. Complete form the group we call the N partition. Here we need to follow the 2 condition. One is one objective should only belongs to one group. Say for example, I have 2 data points. So I have 2 cluster. So in this data point should come with either group A or group B, right? These data points come with any one group. It's not come for common 2 group, right? It's come with any group A or group B. The next condition, there should be no group without even a single purpose. We cannot make a new group. At any cost, right? So these 2 conditions we follow the partitioning method. So in the partitioning method, there are 2 algorithms are there. One is k-means algorithm, another one is k-mediate algorithm. Today we are going to see k-means clustering. What is k-means clustering? The other name is a centroid based clustering techniques. I will tell how to working on k-means algorithm. First, we can ask input parameter k from the user. First we can get input parameter k from the user. For example, k is equal to 2, right? The user we can get input parameter k is equal to 2. That means what? We have to only create 2 cluster, right? Now we can collect the data set. We can take the data points. We can collect the data set. We can take the data points. These are the data points, right? Now the second step, we can choose one random centroid point. For example, I will choose on this data point as a centroid point. The third step, we can find the distance. We can calculate the distance. How we can calculate the distance? So here we can apply Euclidean distance and Manhattan distance. So there are two distance calculation formula is there, but in this technique we are applying for Euclidean distance algorithm, right? Apply the Euclidean distance algorithm and calculate the distance between the objects, the centroid point objects, and we can make form one group, and we can make form one group. And the next step, we can calculate the mean value. Next step, we can calculate the mean value. We can calculate the mean value. What is mean value? It is average of total data points. So we can calculate the mean values, right? We got some values. We will receive some values, right? So again, we can shift the data, right? For example, this is also one of the data points. We can try to shift for group 1 to group 1 and group 1 to group 2, right? And calculate the distance and calculate the average value. If it is comes same value, we can stop the process, right? If it is come the same values, stop the process. If it not get same average value, we can continue the steps. We can continue these steps. This is the clustering algorithm. This is the working principle of clustering algorithm, right? So this is the algorithm. The first we can get input. The input, the k number of cluster in which the data set has to be divided, right? So first of all, we will receive the data points. First of all, we receive the data set. First of all, we receive the data set. In that, how many clusters needed? That means how many classes needed. For example, the input, the user give the input k is equal to 2, right? The k is equal to 2, right? That means what? We have to classify only 2 cluster, right? The next, the data contain n number of objects. See, in the data set we have the n number of data object, right? So without a single image we can't classify, right? We need the large amount of data set. And then output, the data set of a k cluster. The output, we have to segregate the groups, segregate the clustering, right? And the method. So already I told the method. First we can choose one random centroid point and find the similarities of the data points, find the closest distance objects, and we can make we can calculate the mean values, and when the mean value come for the same, we can stop the process until we continue the process. Okay, so next we can see one video, we can get and understand. So these are the data objects, data points, right? So what is the first step? We have to choose 3 random set. First of all, we have to get input parameter k is equal to 2 or 3, right? So here we can get k is equal to 3, right? That means what? We have to choose 3 random centroid points, right? So I will choose on 3 random centroid points, right? And calculate the distance and making the group, right? So this I will choose on these data points here. I will calculate distance. This is closer to this one. This is closer to this one. This one closest to this one. So these and all one group. Similarly for this one, this and all one group. This and all one group. Right. Next we can calculate the average value. Right. If you are taking this average value, it's come for 4 only. I am taking this average value. It's come for 4. This taking for the average value come for 5. So it's come for the same mean value. So then we can stop the process. So now we made the 3 clusters. Right. So this is the flowchart of, as I said, this is the flowchart of clustering algorithm. As I said, we can go for with the values. We can go for example with the values. Say for example, read the questions. Suppose we want group the visitor to website using just their age as follow, right? So the different age people visiting the website, right? So now we are going to segregate the younger people, right? Less than 30, like younger people we can make one group, and older people we can make another group, right? So so here see here we data received from this one 16, 16, 17, 20 until the 26, right? This is the our data set, right? The next step we have to initially form the input parameter. Initially we have to ask we have to get the input parameter k from the user, right? So here we can get the input parameter k is equal to 2, and so k is equal to 2 means what? We have to choose 2 random centroid point. We have to choose 2 random centroid points. I will choose on 16 and 22. I will choose on 16 and 22, right? So what is the next step? What is the next step? We can calculate the distance, right? So I will choose two random centroid points, 16 and 22. 16 and 22, right? So now we can calculate distance. 16 is closest to the this 16, this 17 is closest to the 16 is closest to the 17, right? And then we have some distance, 17 to 20 we have the some distance, right? Now coming to the second cluster, 22 is closest to the 21, 21 is closest to the 20, right? So now remaining all the points are another group, right? So now we received the two cluster, right? So 16, 17 are one group and remaining 20 to 66 are another group. Now we received the two groups, right? Now we can calculate the mean value. We can calculate the mean value. So this is, we got 16.33. The second cluster we got 37.25, right? So now go for the second iteration. The 16 to 17 is not beyond long distance. So we can add the 20 on first cluster. If adding the 20 clusters, the nearest data points also come in the cluster 1, right? So the 20 is closest to 21, 21 is closest to the 22, 22 is closest to the 23. So these all groups comes in the first group, right? And 23 to 29 here having some distance, right? So we can keep it on second group, right? Now we can take the mean value. We got the mean value like cluster 1 19.55 and the cluster 2 we got the 46.90, right? We got these two mean values. Next we can go for the second iteration. We can calculate. Next we can add the one more data point. The 29 is closer to the 23 only. Then we can add the 29 here, and we can again we got some distance 29 to 36, right? So remaining can keep on the cluster 2, right? Now we have to take the average value. So 20.50 we received from the cluster 1 and 48.89 we got the cluster 2, right? So again we have to check any possibility to move from cluster 2 to cluster 1. See here the 36 are there. 36 is long distance between the 29. So we can keep it at the same values. Then we can get the same mean value. Then we can stop the process, right? Now we received the two cluster. One is 16 to 29 is one cluster and 36 to 66 is another group, right? So this is the concept of k-means clustering algorithm, right? Next we can see the hierarchical clustering. So what is hierarchical method? Hierarchical method works grouping data into tree of cluster. So here we can make a data point as a tree of cluster. We can make a cluster like a tree format, right? So here we have to follow some rules. First of all, we need to consider every data point as a single cluster. Say for example, these are the data points. The first step, we can consider each and every data point as a single cluster. So each and every data point we have to consider as a single cluster. The second step, identify the two cluster which can be closest to together. The second step we can identify which is more closest together. We can merge the data points, right? So for example, these two are more closest. We can merge the first two cluster as a one group, right? So merge the two maximum comparable cluster, and we need to continue this step until merge a single cluster. Right? So next we can find out which is more closest to cluster, right? For example, this cluster and this cluster are more closer. We can merge like that until we have to merge complete one group, right? We can go for an example. right? So here hierarchical method we follow the dendrogram diagram. Hierarchical method we follow the dendrogram method. So there are two method is there. One is bottom up V method, one is top down V method. Bottom up V method we called the agglomerative method. Top down V method we called the divisible method. Now we are going to see agglomerative method. So what is agglomerative method? Already we set for a hierarchical method. Same algorithm only you have to follow. The first of all we need to consider every data point as a individual cluster. First of all we need to consider every data point as a single cluster. The second step, we can merge the nearest pair of the cluster. We can merge the nearest pair of the two cluster. Until form a one cluster, we can continue the process. Right? Until form the one group, we continue the process. Right? Say for example here, I received the data, I got the data, I have these 6 data points A, B, C, D, E and F. For assume that I have 6 data points A, B, C, D, E and F. Right? So now what is the first rule? What is the first rule? We have to consider every data point as a single cluster. Every data point as a single cluster. See, I have to take A as a single cluster, B as a single cluster, A as a single cluster, B as a single cluster, C as a single cluster, D as a single cluster, E as a single cluster, F as a single cluster, right? What is the second step? Which is more closest to together, which is more two cluster closest together, we can merge the cell, merge the cluster, right? So see here, the BC are more closest, right? The BC are more closest, we can merge the two cluster B and C, and check the other similarities groups, right? D and E are more closest, we can merge the two cluster, right? Now we can see available clusters. Now we can A is one cluster is there, BC one cluster is there, DE and F. Now we have 4 cluster. The third step, we can find which is more closest together, which is more closest to together, right? So DE and F is are more closest, then we can merge the DEF as a one group, right? Now we can see A as a one, now we available cluster A1 is there, DEF1 is there and F is 1 is there. Sorry, A is 1 is there, BC 1 is there, DEF 1 is there. Now we have only 3 cluster. Next step, again we have to check which is more closest. Which is more closest. So BC and DEF are more closest, then we can merge the BC DEF as a one group, right? Now we can see the available cluster A and BCDEF. Only 2 cluster is there. Then we have to merge the. What is the last rule? What is the last rule? We have to merge the until form a one cluster, right? So now we can merge A, B, C, D, E of a one group, right? So this is the way of hierarchical method. Sorry, this is the way of agglomerative method. So divisive method is nothing but just opposite of agglomerative method. Divisive method is nothing but just opposite of agglomerative method. Just we can do the process of reverse side, opposite side, right? So for splitting the groups is called the divisive method, right? Next we can go for one example. So see this video, right? We have received the data points Max, Alan, Caro, Joe, Lizzo. These are data points we have received, right? Down we can draw the dendrogram diagram, right? First you can see what is the first rule? We have to segregate. The first rule? We have to make each data point as a separate cluster. So these are the data points. We have to make first a separate cluster. What is step 2? We have to merge the two cluster which is more closest together, right? So Joe and Lizzo are more closest. Then we can merge the two data points and we can connect the dendrogram diagram. And then second one we have to check which is more closest, and Max and Alan are more closest. Then we can draw the one dendrogram diagram. And third step, again we can continue the process. Again we have to continue the process which is more closest. Now the Joe, Leo and Caro are more closest. Then we can draw the dendrogram diagram like Caro it's merged with Lisa and Joe, right? And the next step we have to make which is more closer together. Now Chiara, Joe, Leo, Liso and Max, Alan, right? Until forming one cluster, we have to continue the process. Now we are completely formed one group and we draw the dendrogram, right? And finally we got the output like complete dendrogram diagram, right? So this is the process of hierarchical method. Next we can see density based clustering in data mining. Next we can see the density based clustering in data mining. So first of all, what is density? It is nothing but mass by volume, right? So some data points are located in the massive volumes. Some data points are located in the massive volume. See, for example, generally we can see for the other two algorithm the data points like that, right? So here we data point is there. You have to choose one random data point and which is more closer, we can merge the data points, right? Generally we can see for this type of data points. But density based clustering, see here some density of data, like some data points are located in a density way. See, say for example, the first data points to the last data points very long distance, but it is in the same group because the density the data points are located in the located in the data set, right? So this is another name is called density based spatial clustering of application with noise, right? We can go for how it's working for the density based clustering algorithm. So here we need the two parameter. Here we require for two parameters. One is epsilon, another one is minimum points. Here we need the two data points. One is the epsilon, another one is minimum points. So what is the epsilon? Say epsilon is nothing but neighbors of data points. Epsilon is nothing but neighbors of data points. For example, these are the data points, right? Here we can choose one epsilon data point and make radius of circle, and we have to make one radius of circle. Choose this epsilon data point and make one radius of circle, right? So this is epsilon data point, right? So what is minimum point? So minimum point, the condition should be unsatisfied. For example, the user give the minimum point is 4. The minimum point is 4. So this condition should be satisfied on the radius of circle. See for example, see here. Here we can check the minimum point is there or not. Sir, see here 1, 2, 3, 4, more than 4 point is there. So the condition it is satisfied. So this epsilon point is a satisfied the minimum point, right? So in this algorithm, we have to follow the three types of data points. In this algorithm, we have to follow. In this algorithm, we have to follow three types of data points: core point, border point, noise point, or outlier point. What is core point? A point is core point if it has more than minimum points or points within the epsilon. Right? Already I told. If the minimum point is satisfied, then it is called the core point. Right? Already we made one epsilon with radius of circle, and we have to check the condition the minimum point is satisfied or not. So this minimum point is satisfied. So this epsilon point is called the core point. Epsilon point is called the core point. Right? Similarly, what is the next is data points? Border point. Next data point is border point. It is located on the border and which is not satisfied in the minimum point, then it is called the border point. Border point, right? And what is the third data point? Outlier point. So completely deviate from the circle. We called the border point. Completely deviate of the circle, we call the noise point or outlier point, right? So this is the way of to measure the data points in the density based clustering methods, right? See this diagram. See, I will, first of all we need to get the input from minimum points and epsilon. So minimum points here they mentioned 4 and epsilon 1 unit. And now find the epsilon point. I will choose on this epsilon point and form the make the radius of circle. I made one radius of circle, right? And then we have to check this is the core point or not. If we, how we can check the core point? If the core point means this satisfies the minimum point, it is satisfied on the minimum point. So check here minimum points is there or not. So here minimum points are there, right? Here more than 4, we get the data points are more than 4. Data points is more than 4. So these conditions are satisfied. So this is called the core point. So the border point in this radius of circle, some data points located in the border, that is called the border point. Completely deviate from the noise, it is called the outlier point or noise point, right? So this is the way of calculating the this is the way of calculating the density based clustering. And thank you for listening me. Thank you all.